Yes.
Okay, thank you. All right, so the first thing that you might notice is, for example, let us take a look at this particular example where this is for understanding the preferences for a new energy drink. Okay, so the attributes you can see are caffeine, calories, vitamins, and price, and there are different levels to these. So just as we had discussed in the class, that has been converted into an X matrix over here. Um, that is over here. So where D0 stands for caffeine level, if that group is here and I say something that is not aligned with what you intended, please point that out. So for now, I'll just rename this as decaf so that we all can easily understand. Whenever you're giving some names to the dummy variables, make sure they are in a way that you can understand. So it took me a little time to go back to those attributes to figure out what was happening. And so the first is caffeine and the other one is calories. So let's call it as decal. So there are 3 levels of caffeine. So this out here is the base reference category. Same way for calories. This one is the base reference category, that is 200. Then vitamins, there are 5 levels. And which ones have been taken? So vitamin B, vitamin C, vitamin A and B. So the reference category is B and C. And same way for the price is still easier to understand. So this is your X matrix, and out here is the Y matrix. That is the respondent. Preferences, ratings for each of the different options that the group uh, showed to their respondents. Now, I want you to take a look at this X matrix. It has some interesting patterns that you need to be able to figure out. So do you see, look at row number 68, okay? It has 0, 0, 0. And then again, from column F to I, there are zeros. And then again over here, zeros. And this entire row of observations has zeros. And then look at this particular column. Again, there are many zeros. And then look at this column, lot of zeros. Okay. And this is not a mistake that the group has made. This is the design that was generated. And because you had a limitation to use 13, so it is purely, because of the design that has been generated, design tried to balance out. But this is a common issue that arises in conjoint studies. And in regression. So even if you collect data from the market, let's say a company gives you the data on credit card purchases or, who swiped what type of reward cards. This is an issue that can arise in secondary data as well. The key thing to remember is whenever a column has a lot of zeros and the next columns, multiple columns have a lot of zeros, there arises a problem called multicollinearity. So if I just do a regression, not a regression, if I just do a correlation of all these variables, okay? So in your earlier lectures in marketing analytics, the first few lectures discussed that before going ahead with regressions, the very first step is to look at scatter plots, to look at correlations. So this is why we need to look for correlation. So I'm going to highlight this entire data, and I'm going to go to, do you all have in this data, that data analysis tab, do you have that here? Let's see. Otherwise, I'm going to take this data into another different file. Okay. All right, so I'm going to share, let me just copy this entire matrix. For now, I'll just copy 34. And I'm going to open a new file. I have it here. Can you see the new file, or do I need to stop sharing and reshare? Can someone let me know? What do you see on your screens?
We can't see the new one.
You can't see the new one? Okay.
I found that if you open the sheet in the Excel, like the actual app, it lets you have the data analysis option on there.
Ah, right.
It's
Okay.
just because you're in the browser, it doesn't.
So it's not showing that option. Okay, let me just pull it into this particular file and I will share the new file. Okay, right. So now let's take a look at this file. Okay. Now let's do a correlation of the entire matrix. So just select the entire matrix and go to data. Data analysis, go to correlation, click on OK. Input range, so it's not taken by default. So let's just select the entire data. And labels in the first row, output range, let's just output that out here and click on OK. Maybe. Oh, it's hanging. Okay, it's got stuck. Just bear with me for a moment. All right, so I'm going to share my screen uh, with a different software because I just want to show you what is what are the ramifications of using data that has high collinearity. Okay, so these are all your dummy variables. Let's see. Okay. So now you will notice I just ran this correlate command and it has calculated the correlations. So if you spot any correlations greater than 0.5, those are strong correlations. Okay, so let's copy this table onto an Excel file. And so now you will see that, okay. So if you look at this particular data, anything above 0.5 is very strong collinearity. So for example, this particular number here. Now you will notice that, okay, data, text columns. Okay, now let's highlight the numbers. So you can see this is strong collinearity. Okay, if I take a look at the numbers in this particular data, all these seem okay. This is also on the higher side. It's borderline, but it is 0.4. It is quite strong. Okay, this is okay. This is another one.
I think the
And
second one that you did is a negative 0.4.
which one?
The
This
one,
one?
yeah, that one.
It doesn't matter because it is close to whether it is negative or positive. If it is greater than 0.5 or it is on, whether it is on the positive end or the negative end, it becomes strong collinearity. So whether it is positive collinearity or negative collinearity. So that becomes an issue. So these big numbers out here, these create a problem. So it means that the dummy for vitamin D is high, for vitamin B is highly correlated with consumers' preference for vitamin A. Now, I don't know why consumers think that A and B are similar, but that seems to be a perception. Or no, in this case, it is not the consumer preferences. This is the design. This is the X matrix. So maybe the group, um, when they looked at the different vitamins, they thought A and B are very different, which even I would like to think so. But a lot of the profiles have A and B combinations occurring together or not occurring. So that is why it is leading to multicollinearity. Same way that there is collinearity between the price for dollars and vitamin C. So the combinations which have vitamin C might also frequently have a price of $4. So this is essentially what it means. So whenever this is just a small example, and I can see that here the collinearity is not all that high, but some of you might find collinearity to the levels of say zero point 0.7, zero point 0.8, even zero point 0.9. So in the past, I've seen perfectly collinear variables to the point of being 0.90, 0.95. So that becomes an issue because what happens is the model does not converge. So the entire regression is based on linear algebra, matrix algebra. So those of you who have an experience of matrix algebra. So I'll just briefly show you what happens in that. I'll, share a package called Paint. I'm not great at painting, so it'll be pretty rough, but you should be able to. So your regression equation is equal to y is equal to x time beta prime x. So I'm just writing in matrix algebra language. So these are the betas. That's all that you've got to understand. This is x matrix, this is the y matrix, and this is your error term, right? So this is your entire regression model. So when the linear regression runs in the background, what exactly happens? So to recover the betas, the matrix algebra formula is x prime x. This little symbol stands for prime, which means inverting the entire x matrix and then taking a prime of the, this is multiplication. So if it is a row vector, it gets converted into column vector. That is the meaning of prime. So x prime, that is x transpose, is multiplied by x matrix, and you take an inverse of that matrix multiplied by x prime y. That means x transpose multiplied by y vector. And this is how the entire vector of betas is recovered. Now, if there is multicollinearity, that becomes an issue over here, because now you can no longer calculate the determinant of this particular matrix. So that is the mathematical part, which you don't have to worry, but it is important for you to understand why multicollinearity becomes an issue, because it does not let your model converge mathematically. So the way to deal with it. So what are the repercussions of having multicollinearity? So now I'm going to come back to that Excel file. Is that now let's say we want to run a regression. So we come back to this particular slide, and I have this annoying message. Save the ones you wish to keep. I don't know how to get rid of this message. It's making my screen a bit smaller. Let's say close. And yeah, it wants to save or not save the file. Okay. All right. So now we have over here this particular matrix, and let's run a regression to see what is going to be the outcome. So this is your independent variable matrix. These are your preference ratings. That is the Y matrix. Okay. Now let's take, so let's go to data analysis and click on regression. Okay. Input the Y range. I've selected the entire Y range. Now I'm going to select this X matrix. Okay. There are labels in the first row. The output range, let's take the output on a new worksheet and click on OK. Okay, so now let's try the first regression. In my laptop today, Excel is giving an issue. Maybe I'll have to reload it. I have no idea why. So now let's run a regression over here. And our first dependent variable is respondent one's ratings. And then we have all of these variables. So I'm going to have to work a little harder the first time round to copy these variables.
Hi, just
Mhm.
wanna ask, so this one is like this, I just like wondering which app that you're using right now.
Right now, I'm using a software called Stata. It
Oh,
is, I love this software. It is very good if you have up to 1 million observations. And run mathematical models. I use this if those models are not complicated and if my data sets are up to 1 million observations.
oh,
So, yeah, this is a
because
very advanced software. And if you're wanting to go in the field of analytics, then I would suggest do a training. It's free, I think, in the in UTS. You must know SPSS and Stata and SAS if you are in Australia, because I think IKEA uses SAS and there are some companies that use Stata. But I love Stata because for simple models, it's really good. It's very fast.
oh,
Okay,
okay.
now you see this regression. This regression um, has not produced any results. It's just given dot, dot, dot. In case of Excel, when you run the same regression in Excel, it is going to print NaN, N-A-N, N-A-N, N-A-N. I'm sure that some of you will see that in the output. And the reason is, like Stata has told you, it is because of collinearity. So I could, in this case, actually, let me try and see if this command works. It'll also show you the degree of collinearity. So this option is not allowed here. Okay, but Stata has told you that these variables are highly correlated. So coming back to the key issue. So when you notice that the correlations are very high, like we were seeing in that particular Excel file, right? So what we do is, in that case, it's best to omit these variables. That is the best thing to do. Um, let me take this particular file. Just bear with me. And okay, I think I have to renew my Office 365, which is why I'm getting these messages. So when you have multicollinearity, the variables which are highly collinear, in that case, it is best to remove those variables from your regression. So now in our case, data has told us that these variables are highly correlated. So we are going to remove the price level of 3. We are going to remove the price level of 4. What is 350? It is 3.50. So probably because these price levels are very close anyways, so we must remove them. Other than that, you can also see in the correlation matrix, it was telling us that these two variables are highly correlated. So there are a number of ways to deal with multicollinearity. Either you remove one of them or you remove both of them. So let us work this way, just so that, there are different, you will have to experiment. So if I were you, I would first probably run the model. In my case, Excel is not working, but I'll highlight. So I will have to keep switching. Hang on. I will have to keep switching between Stata and Excel, but that's okay, so long as you're able to follow. So in $3, $3.5, $4 are highly correlated, okay? So I'm going to put all these columns. I want to highlight the columns, so let me just put them in red for you to see right now. It's just disgusting me no end. Okay. I'll try and work in the same file to show you. Okay, so what we're going to do is you have a number of choices that you can make decisions in different ways. If these three columns are highly correlated, you should remove these columns, okay? And retain only one. For example, these three are highly correlated. So we could probably remove 3.50 and 4. Or another way to see is which of the columns has greater number of ones. So for example, $3 has too many zeros, right? Same way, $4 has too many zeros. So what we can do, it doesn't make the best sense over here, but you have to see what works best. So maybe we can remove, also, I will point out over here that the group has chosen these price levels in a way that they are very, very close, 2.65, 3, 3.5. So now, because there is collinearity, it is very hard to make that decision as to which variable to remove. But in this case, because the group will have to take a decision, so let's just go with the best case scenario in this case where there are maximum number of ones. So this, I think 3.5 has 1, 2, 3, 4. This one has only single one variable. So this is a big red flag. Okay, give me a moment. My cat Clippers is now agitated because he wants some treats. So whenever he notices I'm on my laptop at night, he, takes his tax. So I have to give him some treat. So this is a big red flag because there is only one single one in this particular column. This column has only two. So let's keep this column and remove the other two from the regression. So that is, let's go back to my software. Where is data? Okay, there you are. So once we remove these columns, the results should be better. So we are keeping only 265 and 350. Okay, let's try and see what happens. Okay, so when I remove those two price levels, now you can see that the model has converged. This is what happens when there is multicollinearity in the data. So this is live demonstration here to you. So this is what we were getting. In Excel, if you're going to run regressions, you might not get dots, but you will have something called NAN or hash signs appearing. And the moment you remove variables which are highly collinear, then your model is going to converge. Now, how would you interpret the model? So this is a crucial part. Earlier, the reference category in that particular group's case was, let me just go back and see their reference category. Their reference category was a price of $5. But for this group, $3, 3.5, $4 was also, highly correlated. So after having removed it, what the categories that you have removed get absorbed into the base reference category. So now the base reference here is $3, energy drinks priced at $3, $5, and $4. So that's how this is the best case interpretation in this particular case. So whatever collinear variables that you remove, they are all clubbed together and form one base reference category. So at this point of time, do you have any questions? If you are clear, then we'll proceed forward. Just jump onto the mic. I have too many screens right now, and this laptop is not at its optimal performance. So if you have questions, just go onto the mic and ask me. Otherwise, I will continue. Okay, so this was one important thing. And now let us see. This is only with the respondent one's ratings that we have run the regression. Let us run the regression with respondent two's ratings to see whether there are any other issues, or is this model going to run fine with all of the respondents, right? So it seems to run okay with the second respondent's preference ratings as well. So more or less, we have removed those collinear variables. It is okay. So you can take these part words and, work with these part words. But I also want to show you another interesting thing that is happening in this particular data, although this is just for your additional knowledge that the R square in this particular model is 0.90 and the adjusted R square is 0.40. So, okay. So this seems to be a reasonably okay model. But for the second respondent, the R square is 0.82 and it goes down to the adjusted R square goes down to negative 0.03. So whenever there are variables in the model that are not helpful in explaining the consumer's preferences, the adjusted R square goes down. So it actually says that the model is able to explain the preferences for the respondent one in a pretty fairly okay manner. But for respondent two, either the respondent has not been careful in indicating their preferences, so this model is not capturing their preferences in the best way possible. This is just some additional understanding for you all, but that should, for now, for your projects, all you are interested in is that the model should converge, and you should have this set of coefficients that you can then copy and, paste into part worth matrix. Okay. Any questions so far? So you're going to run the models for 5, 6, up to 10 respondents to make sure that your regressions are going okay. If still you continue to get the problem of convergence, then you have to experiment with which other variables I should take out from the model. Let's say you had collinearity between these 4 variables also for some other respondents. Let's say for the first 5 respondents, the model was working pretty okay with all of these. But then for the next 5 respondents, even this variable was giving a problem and the model was not converging. In that case, what I would do is uniformly across the respondents, I would remove this particular variable called VCAF80 if I find in my regressions NaN coming out for this variable. Okay. So, but whatever you're doing, the kind of regression that you're running with the variables, it has to be uniform across all of the respondents so that you can create that part worth matrix. And it is important to have uniformity of variables because this matrix is going to feed into, later on down the line for clustering. So otherwise you will not be able to get clustering results if you have different variables, different X matrix for few individuals and another different type of X matrix for the rest of the individuals. So that is the main point here. This is the main issue that you are going to come across. So give me a moment. I have to let my clever cat clippers out. Otherwise, he will keep me on. Okay. Any questions over here so far?
So I have one.
Mhm.
Um, so like, I think I just missed a part, but like, how can we, like determine that respondent, like that role is kept like good? Because like earlier, you just like remove one of the role, and yeah, it's just like wondering how can we kept like evaluate whether is it good or not?
You mean to say the X variable
Yeah, the
which are
experience.
removed? How to
Yeah,
determine which to remove, is it?
yeah,
Okay, that you're going to determine by calculating the correlation. So like in my case, the Excel is not working. Otherwise, I could have shown you. But if you go to select your entire X matrix, okay,
yeah.
then go to data analysis. For those of you who are here, open your file and do this. Select your entire X matrix, go to data tab, go to data analysis, select correlation, and in that correlation, feed in your entire X matrix. Click on labels and then click on OK. And it is going to show you the correlations. And then identify which are the highest correlation, 0.9, 0.8, anything above 0.5 or anything below 0.5, negative 0.5. Those are all very strong correlations. So if you have two variables which are showing very high correlation, for example, in my case, it was, I will show you back to the correlation. These variables were highly correlated. D underscore C, D underscore 4. And I was also having issues with D underscore 3, D underscore 350, and D underscore 4. So actually, after I removed D underscore 4, then this became okay and the model converged. So you have to see if this is highly correlated, for example, D underscore C and D underscore 4, remove one of these variables, whichever one that makes sense to you. And whichever is the one that you remove, it is considered as the base reference category for that independent variable. Does that make sense, Pam?
Um, yes, but like, do we have any cap like, if I want to watch it again, do we have like, in the tutorial, like,
This is being recorded, so
oh yeah, oh
I'm
right,
going to
thank
share
you.
the recording with you.
Yep, thank you.
Okay?
Yep.
Any, go ahead if you have more
Yeah, I
questions.
have one. I mean like two. So
Mhm.
like during our report, it will be more kept like better if we add some secondary research into the report, like for to solid kept like strengthen our segment, our analysis.
Well, you can do that, but you have to remain within the word limit. So you have to
Oh,
have
yeah.
a good balance of how much secondary research you are doing and how much of actual research you are doing.
Oh, yeah. Okay.
Yeah.
Sure.
Okay. Any other problems related to the data? First, let's cover the data analysis part.
I had a question.
Mhm.
So after we run the regressions,
Mhm.
we have to run we have 70 respondents. So we have to run 70 regressions, correct?
Yeah. Yeah.
Yeah. So after we do that and we get all the coefficients
Mhm.
of each attribute, are we supposed to average it out?
Okay. For what to do with those coefficients, you will get that part worth matrix, right? Now, I have sent you the link to a file. Let me show it to you. I'm going to open my canvas. There is no one right technique. So what you will have to do is you will have to listen to this particular video on how to analyze um, the part worth matrix. I'm just opening that and showing you. So let me share the screen. I'm in Canvas. So if you go to the module for, I think, week 8, where we have done conjoint regressions. So week 8 tutorial, conjoint regressions. Go to this particular module, and over here, I have uploaded 2 videos. One is the basics of conjoint regression for those who don't know what to do with the survey data. Okay. The other one is part worth analysis. Listen to this particular recording. This shows you what to do with your part worth matrix. Uh, I've recorded different ways of looking at the part worth matrix. Either you can create an ideal product profile, or like you said, you can average the coefficients across all of the individuals, but then I don't know what that average is going to tell you. So with averaging the coefficients, you can do, sort of describe the part worths. That is the best you can do. That the average preference across the entire 70 consumers is, let's say, higher for vitamin C as compared to vitamin B, and so on. And that is perfectly okay. There's nothing wrong in that. All right. But this video also shows you how to create the ideal product profile. Um, you can plot those part words to see you can create scatter plots to see which patterns emerge. And then you can take the interesting patterns and then you can, talk about those. Uh, so yeah, so I would highly recommend and encourage you to watch this particular video. It shows you step by step and describes, what type of analysis, what does it mean. You can convert the coefficients into utilities, and what do those utilities tell you? So it is something along the lines that you got in the quiz questions today. So is Sophie's utility for Pepsi higher than David's utility for Coke? Or, you can calculate those utilities and come up with um, some sort of description across the entire cohort, or you can see if you see some patterns in the data. Does that make sense,
Yeah.
Mama?
Thank you. Thank you.
Okay. All right. Any other questions?
Sorry, just to confirm, the part worth is like the coefficient, right, that we get from the regression analysis.
Hmm.
Um, and then also another question, last week during the tutorial, um, I asked about preference rating, but I still didn't get it, like how you got your preference rating
Mhm.
in that Excel. Do we need to do that in our assignment?
The preference ratings you would have recovered from your survey. So let me just share this one more time. So this group had shown these profiles to the respondents, right? So in their case, they have how many respondents here? So they had 13 profiles and about 56 respondents. So each respondent had given a rating to each of these 13 profiles that on a scale of 1 to 7, how likely are you to buy this particular combination of energy drinks? So this is what you're going to get from the survey document. Does that help you understand when you download the survey data from Qualtrics?
Mm,
No,
Wait, so
that's
how did you get those numbers then in the Excel? Like,
okay. So I want you to go to your Qualtrics. I'm trying to open mine if I can show you. I want you to go to Qualtrics and open your survey data. Did you collect data already or not?
yes, we have.
Okay. So if you go to survey, so what can you see on the screens? Are you seeing the Excel file or my Qualtrics?
Your Qualtrics.
Okay, good. So what I'm going to, let me try and hold on. Okay, I don't know which group is this. Okay, let's try with this group. So one of your groups has shared the survey with me properly. So let's go for this. Now, this is the survey document that was given to the respondents, right? Now, in this, what you will see when you are in your Qualtrics survey, you see these numerous tabs over here. You're going to go to data and analysis. And once you come over here, it gives you an option called export and import. You're going to click on this and you're going to export your data. Then it is going to ask you, how do you want to export it? Do you want to export it as CSV file, Excel file, what type of file? Usually, comma-separated CSV files are smaller in terms of their size. So it's okay to download as CSV or Excel, totally up to you. And then it says export values, export labels. I would suggest do the download twice. One is export labels. With export labels, what happens is, let's say the question was on a scale of 1 to 7, rate how likely you are to buy. So if the respondent has given a rating of 7, the label is going to show that number 7 as extremely likely. And then a second time also export it as values. In this file, you're going to see 7 instead of extremely likely. The reason why I'm asking you to download both the files is you can always do a cross check. Or sometimes, because like what I do is sometimes you get confused because there is so much data, and then I have to go back and see what does the label 1, what does the value 1 stand for. So you can, go back to the labels and check, oh, okay, 1 stands for extremely unlikely. So that is the reason. So you're going to download both formats, but when you do export values, your data is going to download in terms of, it'll give you numbers. And when it gives you numbers, let me just download this for a moment, although it's not, my Excel is not behaving today. So I'm now, can you see Excel on the screen?
No.
No.
No, okay. Yeah. Just give me a moment. I'm going to have to struggle with this today because it's just not letting me extract. Let's say I extract all. Okay. I'm going to start. Okay, so these are the files that I have. Now I'm going to just call it as value label values. And here is the Excel file. Let me, okay. Whatever this group is, new development property. If you are here and if you have questions, you can ask. Okay, let's open this file. All right, so now what we have done is, can you see the CSV file now? Do you see that or no?
No.
Okay.
It's not working.
No, you're going to see the, how about now? Do you see the CSV file?
Yeah.
Okay, so when I clicked on download data, download as values, this is how you're going to see. So these are all the individual profiles that they have, this particular group have in their data. So instead of labels, now you see numbers, and these are the preference ratings. Okay, this is the data that you are going to, this is your Y variable. This is for, so this is each respondent. So each row here represents the respondent. So this is respondent one's rating. Let me move this. For option 1, this is the rating for option 2, and so on for all the 13 options. Okay, this is
In the credit card conjoint regressions and part worth analysis, on step 7, which is called dummy coded FFDs design to be used in linear regression, there's a column that has preference rating that's next to the dummy variables. Is that what it is? Like,
yeah. So this is the data that is going to form, that preference rating.
so we have to put that next to every dummy variable.
So you can do like the way that the group has done. You are going to take this and you are going to, arrange it in the way that this particular group has done. Okay, so how group 6, how they have done, what they have done is they have arranged the data in this way. So this is the entire X matrix, and this is the survey respondents ratings. So you have to transpose the matrix from the rows. Qualtrics gave you one row for each respondent. If you transpose while pasting, it'll become columns. So one column for each respondent. Does that make sense?
Yep. So we just have to format it like what you're showing right now and not like what it is in the credit.
Qualtrics. Yeah.
Yeah.
No, even in credit card data also there is a sheet. Look at the regression sheet. It shows you the data to be arranged like this.
Yeah. Okay. Thank you.
Okay. Yeah. Any other questions?
Yeah, I just have a question.
Mhm.
We've actually done like sort of the conjoint analysis, but we've done like two approaches for it. So the first one was we did the individual level regressions for each of the respondents, and then
Yeah.
we estimated the part width utilities, and then we calculated attribute importance using like the range method, like the max and the min, and then we averaged the results. So we got the average of the 70 respondents, and we found which attribute was most important for the 70 respondents, just the average. But then
Mhm.
my other peer, he ran a pooled regression, so across all of the respondents, but it
Okay,
was not individual level. He did it for all of it, and then
that's fine.
he calculated part worth and attribute importance from that aggregate model. I was wondering which approach is better. Like, is it the individual level regressions or
No, but from pooled data, if he's run the regression, he cannot create a part-worth matrix.
okay, yeah, that's what I thought. So
Mm,
we'll use the individual one and
yeah, that would be incorrect
okay. And then
because he seems to have simply I don't know how he's done that. I would really have to look at what he's done, but it is certainly not correct.
okay,
Yeah.
cool. Thank you. And then
Mm.
also, do you like expect us to sort of work out which option the respondents prefer the most? Like, is that an insight that we should put in there?
Very good. I think y'all are thinking along the right lines. You'll have to give me a moment because I thank you for that. Okay, so coming back to your question, you are thinking along the right lines, and you have, if you've done the attribute importance rating individual regressions and formed the part-worth matrix, then you are along the right lines.
Yeah.
And you also looked at the options which are popular. That is another great way to look at, get a feel of what's happening in the data. Yeah.
Yeah. I was just wondering, because like in the video of you doing like the part width analysis,
Yeah.
obviously you only showed us like a one where you did for individual, like one person.
Hmm.
So what I'm confused is it better for us to like do for certain individuals to see like what certain individuals sort of prefer, or is it better for us to average it and then show the results? Like that's what I'm confused about.
So you have to do the individual regressions to create the part worth matrix.
Yeah.
Does that make sense?
Yeah, I've done
That,
that. Yeah.
yeah. So you have, do you want to,
Okay.
yeah.
The pink table is our part width matrix.
All right. So this step is correct. You've done it correctly.
Yeah. And
Now, what was the question about? I
I
couldn't get.
was asking just for the attribute importance. So this is how
Hmm.
I've done it. It's a bit confusing, I think, but
Hmm.
so that's our the pink one's the part width matrix.
Hmm.
And then I've gotten the
The
max and the
range.
min for yeah,
Yeah.
the range for each one. And then I got the total range so that I could get the percentage for each of these ones. And then at
Excellent.
the end, I averaged it so that I was able to find which one was the where there. This is the
Yeah.
that we got. I was wondering if
Okay.
that's like the correct method to
Yeah,
be
that looks okay. That looks
using.
okay to me. Yeah.
And then for our part width analysis,
Hmm.
so I got my part width matrix and then I just averaged like for each level
Hmm.
for here, all of it. And then I
Yeah.
put it in NIST
Yeah. Good.
for all of it. And then I just average, yeah, I put the average part width, so all of it onto.
The average across all of the individuals, right? For price
Yeah, that's
199.
correct. Yeah.
Yeah. So you are along the right line. So you have what you have plotted here are the preferences for the different attributes on an average across the entire population. So now you find over here, for example, the price of 299 is, no, the price of 199 is preferred
Prefer the
as
most.
compared to higher price. So it
Yeah.
kind of makes sense, right? So
Yeah.
look at the graphs, and if they are making sense to you, then that is perfectly okay. So this is the average preference. This is okay. The way that the recording in my recording, it instead of taking average part words, it converts the part words into utilities and then maps the utility, for every individual. That is another way. But I think this is perfectly okay. The idea is to find some key insights, and you can do that. Yeah,
Is
this
this
is
okay
okay now.
to?
Yeah.
Okay, thank you.
All you have to do is you have to do different types of analysis and come up with a story. That is what
Right.
storytelling
Okay.
is all about. What is the story that your data is telling you, right?
Okay.
So your data might be telling you a story which is very different from another group's story. So every group is going to have analysis. Every group is going to do different types of analysis and present the analysis in the report, the ones that best suit or the ones that best tell a story for their project.
Okay,
If
thank you.
that makes sense.
Yeah, that does. Thank you.
Okay, well done, well done. Yeah. Any other questions?
Yes. Are we allowed to ask about the report now?
Yeah, okay. So one thing, because we are recording, so let me also tell you, just before I let you go ahead, Lama. So I have run you through the entire project. Like I've held you for the entire steps of conjoint analysis, which was a part of your group report, right? Right up to forming the part worth matrix. So I'm not going to give you, I'm expecting that you should be able to write a nice report. There's no fixed format for the report. So I'm not going to give a pre-feedback on the report because I'm going to mark and grade on the report. So that is one thing I want to make clear. So Lamo, you can ask any questions that you have now.
I was just gonna ask, like, what are the key things that you're looking for that like can get us the HD level, like the key insights or something like that?
Um, yeah, that's a good question. Again, there's no one standard answer to that, but I would say mostly the HD groups are the ones who go over and beyond. So I will just take this analysis as an example. What Hananshia, am I pronouncing your name correctly?
Yeah, Hannah. Yeah.
Yeah, Hannah. So what the analysis that Hannah has shown, and now if you take those key insights and combine them with what you are observing in the market and make a recommendation that this is what our analysis finds, and the market shows that most of the energy drinks fail because they fail to consider what our analysis is showing. So you're going over and beyond your data to couple those insights with what is happening in the industry. That is one way to do it. Another way is if in that you also explain theoretically that you use a theory to explain that maybe the preferences have changed. So in the past, consumers used to do a certain thing in a particular way. So, for example, um, in the past, consumers preferred to go to the store and buy products, but now our data is showing that most of them prefer to buy products in store. And the theory is because it saves them, according to the search theory, it saves consumers a lot of time. So now you've been able to connect a theory with what is happening in your data. So that is called going over and beyond to explain, to tell your story and then explain why something is happening and connect it with whatever, either it is recommendations or your observations or what is happening in the real world. So that is HD level report.
Okay, thank you.
Mhm. Any other questions? No? Just trying to think if there is any other thing. So while you're on here, let me just show you if any of you are wondering about the format. So what format of the report should we have? Then I will take you back to Canvas information document because it's a free-form report. You have to decide what is the best way to present your story. Okay. So if you have no idea what sections to write in the report or how to present your data, then if you go on to page 3, it says no specific format, but you can take a look at the evaluation criteria of this report. So for example, if you scroll further down, the evaluation criteria for assessment task 2A. Accurate problem identification, suitable selection of experimental design, overall quality of your questionnaire design, interpretation of your analytical results, clarity of communication with visualization, formatting, and writing style. So you can use these and create these as different sections in your report. Okay, so these are 4 different sections. You can divide your report into these 4 sections. Within that, you can have subsections. So that would be a good starting point for you. So this is my key point for the groups that are not sure how to do formatting, how to write the report. So this is how you write. All right. In that case, one last, I'm going to extend the peer review, the date for peer review, because based on the feedback that I've received today, I think more groups are going to have to do peer reviews. So I will extend the date to beyond the date of submission of the report. So submission is on 24th, and I will probably extend it to 28th or 29th, peer review submissions. In your peer reviews, try to submit whatever documentation that you have, evidence that you have. So
If we don't have any issues like with our group, we don't have to submit it, right?
no. Then
Okay.
you don't have to. No. So wish you all the best, and let's stop right here. Yeah.
Thank you for your time.
No,
you.
you're welcome. You're
Thank
welcome.
you.
All the best to you guys.
Thank you.
Thank you.
Have a good night.
Thank
Good
you.
night.